I'm Matt Sigler. I'm a fifth-year grad student at UCLA here in Earth and Space Sciences, and I study ice on the moon. I work with Dr. David Page on the Diviner Lunar Radiometer, which is an instrument that's orbiting the moon right now, and it's measuring surface temperatures. So the moon, is tilted by about 1.5 degrees. And so what that means is that craters that are near the North or South Pole can get incredibly cold, because if their walls are high enough, they block the sun for the entire year, and those craters never see any direct sunlight, and so they can get down to really low temperatures. We've maybe even measured some temperatures down to 20 Kelvin, which is one of the coldest temperatures measured anywhere in the solar system. What I've been doing is modeling where in these situations ice would be stable, and how the ice might have gotten to these places in the first place. So long ago the moon was tilted more, and that would have let these polar regions be hit by direct sunlight, okay? And so they wouldn't be cold like they are today, and so they wouldn't have been cold enough to be stable for there to be ice. But during that time, as the moon's tilt got lower, they would go through periods where they might be very good at collecting ice, and it would still be warm enough that that ice would be able to migrate into the subsurface and be protected from cosmic rays and Lyman alpha light and all these crazy things that we think are eating away ice on the lunar surface. And so it might bury those ice deposits that we might see today. And these same models show that if you have ice depositing on the surface of the moon today, it will be so cold in these cold traps that it won't actually migrate into the subsurface. And so it will just stay on the surface and get eaten away by these things that eat ice away. So basically there seems to be a best time in the moon's history when ice would have deposited. And it's not a very long period of time. And that might explain why there's so little ice on the moon compared to Mercury, which seems like it might have been in this right temperature range for most of its history. The big picture behind ice on the moon. Well, I guess different people would probably give you different answers to why ice on the moon is interesting. There are certainly people that want to build a moon base and want to have water for astronauts to drink, or water that you could use as rocket fuel, right? The space shuttle, its engines were liquid oxygen and liquid hydrogen, which you can get from water on the moon. And so you could imagine a refueling station on the moon could be feasible if you had lots of ice there. But that's sort of a far off way. People like me are more interested in what it tells us about the climate history of the moon, and what it tells us about sort of the climate history of the entire solar system. What are these things that have kept ice stable for all these times and brought it into the inner solar system? One of the main ideas is that things like comets or maybe icy asteroids came in from the outer solar system and delivered that water. And so the Earth has a record of that, but it's all gotten mixed up. In the oceans, in the mantle of the Earth, all these things move around. But the moon has sort of stood there as flypaper, waiting to catch these comets and this ice as it's been delivered. And so it's really neat if we can use these subsurface deposits of ice on the moon to tell us something about the history of delivery of cometary ice into the inner solar system.